Hello everyone, today I'll be talking about how and why humans have developed different skin tones. First, I'd like to talk about how our bodies develop pigmentation. Melanin is a dark pigment produced by melanocytes in the epidermis of the skin, the matrix of the hair, and the irises of the eyes, and elsewhere in the body. Within the melanocytes is the melanosome, which transports melanin to keratinocytes in the skin and the roots of the hair. However, in your eyes, melanin remains only in the irises and is not transported elsewhere. There are two main types of melanin relating to skin and hair, which are called eumelanin and phosphomelanin. While all of us have both of these in our bodies, expression varies greatly. Those with higher concentrations of eumelanin have darker skin and/or hair, as eumelanin is a brown to black colored particle. Those of us with higher expressions of phosphomelanin will have lighter skin and blonde or red hair, as phosphomelanin is a pink to red particle. So now that we've talked about what melanin is, we can talk a little bit more about what it does and how it's produced by the body. Melanogenesis is the process by which the melanocytes produce melanin. There are two types of melanogenesis, basal and activated. Basal melanogenesis is not influenced by external factors, but depends on your genetic composition. Activated melanogenesis occurs as a response to ultraviolet radiation exposure, especially short UV radiation waves called UVB. Activated melanogenesis serves to protect the hypodermis, the skin's innermost layer, as melanin, specifically eumelanin, helps absorb UVB radiation, keeping it from ever reaching the hypodermis. So, why have we adapted different skin tones? While all skin tones are at risk for skin cancer, individuals with lighter skin tones are at a greater risk of developing skin cancer if exposed to the sun for longer periods of time. Those of us with greater expressions of phosphomelanin than eumelanin have a harder time protecting sensitive skin tissues from UV radiation. This can lead to abnormal cell development and malignancies, as discussed in our textbook's Adaptation, Evolutionary Basis for Skin Tone Variation section, which begins on page 531. In addition to protection from skin cancer, increased melanin levels also protect individuals from sunstroke and sunburn, and severe sunburns affect human eccrine glands, which are vital to sweating, the body's best means of controlling body temperature and maintaining homeostasis. And while protection from skin cancer is a great benefit of having increased levels of melanin, it's important to note that it is most likely not the primary factor in the evolutionary selection of darker skin in regions prone to UV radiation. Skin cancer primarily occurs in post-productive years, meaning it's not likely to be genetically inherited either. It turns out that increased melanin in regions with high UV radiation levels positively correlates with fertility. Increased melanin levels prevent folic acid destruction due to UV radiation. According to the Mayo Clinic, folic acid, also called folate or vitamin B9, is crucial to red blood cell formation, and especially for pregnant women, to avoid birth defects in the spine and brain of the fetus. Lack of folate may result in spina bifida and severely reduces the fetus's chance of survival. In men, folate destruction can lead to impaired spermatogenesis, the production of sperm. For both men and women in regions with high UV exposure, folic acid levels are very important, and eumelanin plays a crucial role. And if there are so many benefits to having increased melanin levels and therefore darker skin, why did humans develop lighter skin? One hypothesis is that lighter skin is related to vitamin D synthesis. UVB radiation causes a chemical reaction in the skin's epidermis, leading to the creation of vitamin D3. Before it is used by the body, it travels to the liver and kidneys, where it is ultimately converted into calcitriol, a regulator in cellular replication. Our bodies need vitamin D to absorb nutrients such as calcium and phosphorus, which are vital to proper bone growth and maintenance. Vitamin D deficiencies in children during the growth phase can cause rickets, inadequately calcified, softer, more flexible bones. Those with rickets may develop bowing femora, as shown in the photo here. And adults with vitamin D deficiencies may develop osteomalacia, which is also characterized by softening of the bones, and they may experience more fractures more commonly than those without a deficiency. As humans have migrated to different regions of the world and explored different latitudes, we've encountered and adapted to new environmental conditions. At higher latitudes, there is a smaller angle of solar radiation, meaning energy is less concentrated and spread over a larger surface area, causing cooler temperatures according to the climate sciences investigations. Closer to the equator, radiation is more direct and concentrated over a smaller area, causing warmer temperatures. Which brings us to Glauger's rule. According to this rule, within the same species of mammal, the more heavily pigmented individuals tend to originate near the equator, while lighter individuals are normally found at latitudes further from the equator. It's important to note that while this does apply to a lot of human populations, there are exceptions to this rule, such as the Inuit people, which live in polar regions like Canada, Greenland, Alaska, and Denmark, where you may expect to find individuals with lighter skin. However, due to the reflectivity of light off of the ice and snow that are really common in these regions, the increased levels of melanin protect the Inuit populations from folic acid destruction, just as we discussed with individuals native to more equatorial regions. So in conclusion, our skin tone is dictated by the levels of melanin in our bodies, which is created within the melanocytes and transported to the skin and hair by melanosomes. Eumelanin is a black to brown pigment, while pheomelanin is pink to red. Expressions of eumelanin and pheomelanin make up your hair, skin, and eye color. Melanogenesis is the process in which melanin is produced by the melanocytes and is either basal or activated by external factors. Darker skin tones with higher levels of melanin are more protected from sunburn, sunstroke, and skin cancer in equatorial regions, and protects these individuals from folic acid destruction. Lighter skin tones may aid in vitamin D synthesis, preventing poorly calcified bones in children such as rickets and osteomalacia in adults. All in all, our skin tones are crucial to fertility, bone growth, and development, and are best adapted to our environments. Thank you so much for watching.